In this video, let's review some functions defined by integrals, a few integral problems, and then a couple of free response problems that deal with integrals. So the definite integral of f of x on a to b, which is this, from a to b of f of x dx, is a number. Geometrically, it can be interpreted as an area. Thus, we can deal with something like f of x is the integral from 1 to x of f of t dt using the ideas of area and the properties of definite integrals. F of x is equal to the integral from 1 to x of f of t dt is an integral starting at the lower limit of 1. So let's fill out the chart. And so I'm going to go ahead and start with my x value of negative 1. So f of negative 1 is equal to the integral from 1 to negative 1 of f of t dt. Hopefully you recognize that our boundaries are switched, so I need to negate and reverse my boundaries. So it's asking me for the area between negative 1 and 1, which is all of this, which is just 6 units. It's negated because I had to reverse the boundaries. Let's go ahead and fill out for f of 0. I'm going to go ahead and switch my endpoints. So I've got from negative 1 to 0 of f of t dt. And that's just going to be the area from, well, negative 1 to 0, which is just this. And that, again, would be a negative because I've had to switch my endpoints. All right, so I'm just going to continue. F of 1 is the integral from, well, 1 to 1, and so I know that that's 0. F of 2 is the integral from 1 to 2, and so let's see, cleaning this up a little. 1 to 2, that's just 3 units. F of 3, I'm just going to keep adding on. That's going to be 3 more, so that's 6. F of 4, I'm going to add on, well, I'm going to add on this trapezoid. So I'm going to have to do a little bit of math. Adding the bases, so this is 1.5. So 3 halves plus, and let's see, that is 3, so 6 halves. And divided by 2 times the height. So let's see, how about 9 halves divided by 2, so times 1 half. How about 9/4? And so that's what I'm going to add to 6. So let's see, that's going to be, what, 2 1/4? If I were to write that as a mixed number. So 2 1/4 plus 6, that brings me to 8 1/4. Sorry, I'm switching from improper to mixed numbers. To 5, I'm going to add on this triangle here. So base times height, 1 times 1.5 divided by 2. So 3 halves divided by 2, or 3 halves times 1 half. So 3/4. I'm going to add that. So 8 1/4 plus 3/4. That'll give me to 9. And then I'm going to subtract the same amount below the x-axis, so that'll get me back down to 8 1/4. And then I'm going to subtract that same trapezoid, and so that'll get me down back to 6. Okay, so I hope you followed my little scratch work there. The fundamental theorem of calculus, this is also called, or often called, the second FTC, states that if f of x is continuous on a to b, then the derivative of the integral is equal to f of x. And more generally, and what we saw in our last set of notes is the derivative of the integral is the function evaluated at the upper limit times the derivative of the upper limit. This is really where it's at. And then give you an example. So here are those few sample problems. So we're just going to go ahead and spend just a minute and find f prime of x. And so that is going to equal, well, the function evaluated at the upper limit times the derivative of the upper limit. So this will just give me x cubed plus 1. And the derivative of the upper limit is just 1, so that one's done. All right, this one, I know I'm going to need to switch my boundaries because I've got a 2x, which is larger than the 1 in the lower position. So this is going to give us the negative integral from 1 to 2x of 2t plus 1 dt, which is going to give us, what, 2 times 2x, and this is all going to be negated, plus 1 times the derivative of the inside function times 2. And so we can clean this up a bit. Let's see, this is going to give us negative 4x minus 1 times 2. which will give us negative 8x minus 2. Final answer. All right, number 3. All right, evaluate at the upper limit times the derivative of the upper limit. So I know the derivative of the upper limit is just 3. And if I evaluate the function at the upper limit, this is going to be 3x plus 4 to the 5th minus 3 times 3x plus 4 squared. And I think I'm just going to leave it like that. Let me just make sure I've got minus, did I drop a 3? No, it's fine. We're good. All right, next problem. Function evaluated the upper limit times the derivative of the upper limit. Derivative of the upper limit is 2x sine x squared times 2. And if you want to rearrange that, that's fine as well. And the last one, derivative of the upper limit's 1. So this is just going to be sine of x plus 4. All right, here are the free response problems that I wanted to make sure we reviewed. Let f of x is equal to the integral from -1 to x of f t dt on the interval from -1 to 6, where f is the graph given. Determine f prime of x. Well, that just means we need to take the derivative of both sides of this equation right here. And if we take the derivative of both sides, then f prime of x is going to give us f of x. The derivative of the integral is the function. Okay, so part C, determine the x value where the relative extrema occur. We know extrema occur when the derivative changes from positive to negative or negative to positive. And at an x value of 3, we can see that it's changing. And it's changing from positive to negative, so that means my function's doing this, which indicates a maximum. So it says to justify, so we have relative max occurs where f prime of x, which equals f of x, changes from positive to negative. There is a local max at x equals 3 because f prime of x, which equals f of x, changes. Complete the following table. So we're looking for the integral from -1 to -1 in this case. And so we know that that's 0 because our boundaries are the same. From -1 to 0 would be this trapezoid here, which is 1.5, or 3/2. From -1 to 1, we're going to add on 1, 2.5, so that's going to give us 4. And then we're going to add on 3 more, so that'll give us 7. I'm not sure about this one, so let's go ahead and just figure this out. This is a triangle, half base times height, so half of 1 times 3 is 3/2, and I'm adding that on, so 3/2 is 1.5, so this is 8.5. And then I'm going to subtract that same amount back down to 7, and then I'm going to subtract 3 more, which would give me 4, and then subtract 3 more, which would give me 1. So what is the maximum value of f of x in the table? The maximum value of f of x is 8.5. This does agree. Determine the x value on the open interval where f of x is concave down. Explain your reasoning. All right, so when I'm looking at my graphs, here's my original function. These are just my little sketches. Okay, so what I'm looking at is where f of x is concave down. Okay, so the part that is concave down, this part, is where my first derivative is decreasing. So if I'm looking at f of x, where my first derivative is decreasing, that is going to be all of this right here. And so I can see that between 2 and 4, my function is concave down. So f of x is concave down on 2 to 4 because f of x, which equals f prime of x, is decreasing. Okay, next example. The graph of f is made up of a semicircle and 2 line segments as shown below. Let the integral, let g of x equal the integral from 2 to x of f of t dt. Find g of 2. All right, well, if I substitute in a 2 right there, that's going to give me 0. Nice and easy. Okay, so now let's evaluate the next one. So this is going to give me the integral from 2 to 4 of f of t dt. So from 2 to 4, that is a quarter circle. So pi r squared divided by 4. So this is just pi. And g of 0, well, that's the integral from 2 to 0 of f of t dt. All right, switch your boundaries. Whoops, 0 to 2. And from 0 to 2, it's just going to give us negative pi. And part D, find the values of x in the open interval at which g has a relative maximum. Okay, so g has a relative maximum where g prime changes. If I go ahead and take the derivative of my integral equation, then g prime of x is equal to f of x. So we have a relative maximum. There is a relative maximum at x is equal to 4 because f of x, which equals g prime of x, changes from positive to negative. Write an equation of the line tangent to g at 4. Okay, so we already know this point from the question part B above. G of 4 is equal to pi. So there's our point. So then we just need to find the slope. And the slope, g prime of 4, well, let's look at our, at an x value of 4, our corresponding y value is 0. So if I plug this into my point slope, y minus pi is equal to 0, x minus 4. Or we could just say y is equal to pi. Question F, find the x-coordinate of each point of inflection. All right, so again, I'm going to look at my little 3 graphs. Okay, so I know a point of inflection occurs where my derivative changes from increasing to decreasing. And so I am increasing on this side, decreasing on this side. So I know I'm going to have a point of inflection at an x value of 2. I also am going to have a point of inflection decreasing to increasing at 5. So I have 2 points of inflection. So let's see if we can explain this. F of x changes, and we can say g prime of x, which equals f of x, changes from increasing to decreasing, or decreasing to increasing at an x value of 2 and 5. And then question G, find the range. Now the range, it's not like domain and range. The range is the difference between the absolute max and the absolute minimum. So let me go ahead and write that down. The range is the difference between absolute max and absolute minimum. All right, and so that means I need to break out the candidates test. So your endpoints of your interval are 0 and 8. And I believe, let's see, coming back up here, yeah, g of 0 is negative pi. That was given. And then critical value would be the other value that goes on this table, and that critical value was at 4. And so, let's see, I think we also have g of 4 from above, and that is equal to pi. And so let's go ahead and figure out what the integral is from 2 to 8 is, so that I can evaluate this last one. So g of, whoops, I hate when it does that, g of 8 is equal to integral from 2 to 8 of f of t dt. And let's look at that from 2 to 8. Okay, so we know from 2 to 4 is pi. So this right here is pi. And then this is -1 below. And then let's see, this would be 2 over here. And so if I add those together, that would be 2 plus pi minus 1, or how about just pi plus 1? All right, so we have an absolute minimum of negative pi and an absolute maximum of pi plus 1. So if I take the difference between the absolute max, so pi plus 1 minus a negative pi, this is actually going to give me 2 pi plus 1. I think we have one more to look at. Okay, this one right here. The graph of the function f is shown above consists of 2 line segments. Let g be the function given by g of x, the integral from 0 to x of f of t dt. Find g of -1, g prime of -1, and g double prime of -1. All right, so let's go ahead and get started. G of -1 is the integral from 0 to -1 of f of t dt. All right, I'm going to reverse. So from -1 to 0, that would be this guy right here. So 1 times 3 divided, so 3 halves, this is going to give us -3 halves. All right, so g prime of -1. Okay, so if I took the derivative, that is just going to give me f of -1. Well, f of -1, that's this point right here, which is 0. And then g double prime of -1 is the rate of change at -1. And we can see that the slope of this line right here, I believe it's 3. If I'm going up 3, yep, would give me a rate of change of 3. It's the slope at -1. For what values of x in the open interval from -2 to 2 is g increasing? Okay, so g is increasing where g prime of x is positive. So and since g prime of x is equal to f of x, we can see between -1 and 1, g is increasing. And we could say because f of x is positive. For what values is the graph concave down? The graph of concave down is where f prime of x is decreasing. Or that f prime of x is less than 0, and this means that f of x is decreasing. So g of x is concave down on 0 to 2. Okay, and so the last one wants us to sketch a graph on this interval, -2 to 2. so let's get some values to plot. So I'm going to look at g of -2, -1, 0, 1, and 2. Okay, so I do know a couple of these. This is the first one, the integral from 0 to -2 of f of t dt. Switch the boundaries and negate it. And from -2 to 0, those areas just cancel each other out, and so that's going to give me 0. So I'm going to have the coordinate -2, 0. So that one plots right here. Okay, g of -1. That one was from above, so I'll just go ahead and pull that down. That's -3/2. And so -1, -3/2 would be like right here. And then g of 0, well, the boundaries would be the same. That would be 0. G of 1, so that would just be 3/2. It's just that small triangle that's above. And so at 1, 3/2. And then g of 2, which is the integral from 0 to 2 of f of t dt. And that's the same things happening on the right side that happened on the left. We have this triangular space, which has an area of 3/2. It's going to be negated by this triangular space. And so that is 0. So our function graphs something like this. Okay, so the rest are up to you to work through. And please ask questions as we work through them. And good luck.